Hello everyone, welcome to tutorial 3. As I mentioned earlier in tutorial 2 that in softwares like MPLAB, AVS Studio where there won't be available any library function for implementing software UART, you would have to write your own function for implementing software UART. To help you guys out, I am going to provide you a function which you can easily use in your program. So in this tutorial basically I am going to show you how to use this function. That is, you will be required to receive data from keypad module using UART protocol. The keypad module, as you know by now, will send out data in ASCII hex format, that is in ASCII characters. For receiving the data in UART protocol, the function you will have to use is keypad scan. This function will give you a return value which will be the value received by the pin. Now what will be the pin with which you will be receiving data? You can select that pin accordingly. The pin you will be selecting for receiving data has to be configured as an input. That is, I am using pin RA2 as the receiver pin. So that's why I am configuring the pin RA2 as an input. You can copy paste this in this function in your program, or you can use it as a header file also. The name of the function is keypad scan. The pin you want to use as a receiver pin, you will have to define it using the exact same name as this. In capital letters RCV underscore pin, you will have to use this pin, and then you can define any pin that you want to receive with which you would want to receive data from keypad module. You can write any pin's name that you want in here instead of RA2 underscore bit. So it's the same as like the previous codes. I defined the receive underscore pin as RA2 underscore bit. I have copy pasted my function, the function that I wrote in here up to this is the function. Now in the void main, I configured the bits as required, then I configured LCD display. In the while loop, I am checking whether the receive underscore pin is equal to 0 or not. That is, in standard UART protocol, ideally the output of the transmitter pin from the transmitter side is logical high. When it becomes 0, that means that the transmitter side is transmitting data to the receiver side. That is why ideally the receive underscore pin, which is actually the RA2 pin, will be receiving logic high. When the transmitter side, that is keypad module, will be transmitting data, as an indication of the start bit, the transmitter pin of the transmitter side, that is the keypad module's transmitter pin, will give data logic 0. So the receiver pin RA2 will receive logic 0. So if it receives logic 0, it will mean that the communication just started, the UART communication just started. When it will be detected, you can use the function that I pasted above, keypad underscore scan, and you can save the data in a character naming combine. In here I use the character naming combine. You can use obviously any character, any name instead of this. So I have defined earlier a character combine. Now you have the desired value that you receive from the keypad module, and then you can show it on the LCD display as like the previous codes. So this is a very simple function which you can use even if you want to use it in micro C or any other softwares. You can also use it, as I have shown you. I have used it in micro C Pro for PIC software for microcontroller PIC 16F690. So Altogether, in the tutorials I have shown you three methods. One, you can use built-in UART protocol, which is normally now present in most of the microcontrollers, or you can use library built-in function which is provided in MicroC Pro for PIC or Arduino or softwares for Arduino, or in softwares for MicroC Pro for Aviar, or you can use this manual function to implement software UART. So in three ways you can interface your circuit with the keypad module. In this case, while interfacing your circuit with the keypad module, you can add a pull-up resistor, which I'm going to show you in the Proteus. So let's go to the Proteus file where I can show you the simulation. In here, as I configured RA2 pin as the receiver pin, so the virtual terminals transmitter pin is connected with RA2 and the baud rate selected is 1200. So now you can write 1, 2, 3, 4, and it is shown on the LCD display. So in this program also, the function is written like that. It will receive data in 1200 bits per second baud rate. Now the thing which I was talking about, to add a pull-up resistor. So in here, it is a good practice to add a pull-up resistor. You can use the power option and then a resistor. Just like that, you can use a with pull-up resistor with the receiver pin. Actually, it is also a good option when you're using your microcontroller in the UART receive option, in the built-in UART receive option, or manually you are implementing software UART. It is always best practice to include a pull-up resistor with your receiver pin. This I am ending tutorial 3. For any help or any assistance, you can email me at atul_r14@hotmail.com.